Hi, and welcome to another issue of Festive Tech Calendar 2022. My name is Stas, and I am Microsoft Azure MVP from Ukraine. And today we will be talking about how to build a modern containerized application and evolve it over the time, because complexity usually grows and your application will be demanding more complex configuration and maybe even portability of the cloud to on-premises. So today I will share a few slides and explain the happy path from Microsoft. Then I will guide you through my GitHub repository and explain how to evolve application over the time and show you how to work with different container services in Azure, including Azure Container Instances, Azure Container Apps, and Azure Kubernetes Service, and also explain the evolution, how can you migrate to on-premises with help of additional frameworks provided by Microsoft. But before we begin, I want to share 4 slides with you, so you will have an overall picture, the scope of the services that will be covered in this workshop. So let's begin with info about my company. It's just a brief information, but it's really a fun place to work. So if you have any questions, just ping me back, and we're always hiring. Then moving to the particular technical topic. So the happy path from the Microsoft. Usually you're starting with a web app or static web app as a front end, and then you're developing some kind of an API with Azure Functions. And it's a super simple way to start if you don't have any extra dependencies and can easily tackle complexity with Azure Serverless functions. And the next step, if your application becoming more complex and there is extra dependencies and you need to containerize it, dependencies of application is growing, your next step in evolution is Azure Container Instances. It's a simple service without orchestration and scale of your application. And it's super simple to build your container with Docker and just ship it to Azure Container Instances. You can deploy container groups there, but it's still a service for quite simple cases. The next step is Azure Container Apps. It's a serverless offering from the Azure. It's based on the Azure Kubernetes service, but Azure Container Apps essentially isolating Kubernetes APIs from you, and you receiving the wrapper that can handle your container scale. And it's super easy to start with it, and it's super easy to get benefits from Kubernetes without its complexity. And this is a must-have service if you want microservice architecture without complexity of AKS. Then, if your application continue to grow and you need more dependencies, you can abstract them with the DAPR framework. You can leverage the DAPR power by using DAPR extensions on the Azure Container Apps. They have slightly simplified manifest, but it's still doable, and it's super easy to start with the DAPR. And if you will switch to DAPR during usage of Azure Container Apps, it will be super easy to migrate to Azure Kubernetes Service in case you will need more fine-tuned configuration of the Kubernetes and you need complex configuration for your networking. And if you will start leveraging AKS and continue leverage it with power of DAPR, it will allow you to migrate off the Kubernetes in Azure to on-premises, because there are a lot of cases for this kind of migrations now, and edge services are developing quite fast. And this way you can have this kind of happy path from Microsoft, by building your application, make it more complex and integrate it with more and more services, and essentially make it cloud agnostic with time. And last but not least, the serverless container landscape covers and allows you to ship your containers between different cloud providers and run them without complexity of Kubernetes. On Azure platform is Azure Container Apps. Essentially, it's wrapper over Kubernetes. There is Azure Service Fabric, quite old orchestrator, the native to the Azure cloud, but it won't allow you to scale down to 0. So it's not fully serverless, but the deployment of your containers, they're quite easy and it's quite robust and it's still working, still supported. AWS App Runner, it's not based on the Kubernetes itself, but it's also allow you to run your containers and scale them in the cloud. And Google Cloud Run built on top of Kubernetes with help of Knative framework to run serverless containers and do the orchestration without exposing internal APIs of the Kubernetes. There is also native orchestrator like AWS Fargate from the AWS, and there are also frameworks that allow you to run serverless containers on any environment in any cloud. So you can use Knative or high-scale I/O to host your serverless containers and get rid of Kubernetes complexity. And now it's time to switch to the GitHub repository and start building and deploying our application. Let's go. And so let's start with practical part of the workshop. The workshop is structured around 8 points. Each step of the workshop is independent, so you can skip containerization step and switch to the container apps if you want to, or switch to the AKS. So the crucial components of this workshop is the Visual Studio or Visual Studio Code with .NET Framework 6, Docker desktop application, DAPR CLI if you want to debug your DAPR application on your machine, Azure Client Tools because we will use some command line executions, Azure subscription you can get free from the link inside the workshop URL. Just a reminder that this URL is located here. GitHub, Stas Lebedenko, Azure Container Landscape. And kubectl is also optional but might be required if you will be working extensively with Azure Kubernetes service or Kubernetes on any other platform. So as I mentioned, there is 8 steps, and each 8 step contain a repository with a solution. So let's have a brief look. So the first step is the infrastructure that we will deploy in. Then it's containerization of application built around .NET 6 API. I will briefly mention it. Then we deploying everything to the container instances. It's still the monolithic application with one solution, one project. Then we test in Azure Container Instances group. Here on this step we split an application into services, DAPR orders and DAPR delivery. So it will be one solution but 2 services for convenience. So we would open only one solution at the moment. Then we will switch to the container apps. Container apps will contain additional configuration steps explained in this README file. Then on the step 6 we will add DAPR manifest to the container apps. It will be publisher subscriber component, and we will replace HTTP communication between our services with this PubSub component. Then we will deploy our application to the Azure Kubernetes service. We would also use the YAML components here. Additional components like DAPR PubSub service bus, some secret components, and deploy manifest for our services here. And the last step would be to migrate and switch components from the Azure Service Bus to the RabbitMQ, so we can lift our application to any platform that can host Kubernetes, and we can deploy our components and services there. So one of the crucial points here is, as I mentioned before, everything can be skipped, and each point and changes on each point is well documented in this README. It's quite extensive, including deployment process and changes to manifest and possible issues here. And what else? You can also watch the history of commits of this repository. So if you can see the last step, step 8 initial commit, it took the entire new files in the folder, and then step 8 update, it's changes to this folder. So it's changes of from the Azure Store from the Service Bus queue to the Service Bus topic, changes to the manifest, and etc. So it's easy to track. So it's step 6 initial commit and step 6 DAPR update. So you can do whatever you like and whenever you like, and can return to any step of this workshop later on to check for the changes and to implement it at your own solution. But overall flow, as I mentioned before, it's a happy path from the Microsoft. how to start working with containerized applications and migrate them between services when your solution and project grows and require more and more complexity and attention. So with this said, let's continue to the step number one. Step number one is the infrastructure. The easiest way to deploy our infrastructure is to just copy paste it from GitHub. But one important note: as you can see, I'm getting the subscription ID by querying the name of the subscription. My subscription name contains name Microsoft. So essentially, I'm checking if it's a correct one, and then doing the AZ show. So if I will copy paste just the first 4 rows, I will open the Azure portal. As you can see, some components already deployed, but you shouldn't worry about copy pasting and running the script, because I'm using the random postfix, and the newly deployed infrastructure will have this postfix just with different name. And we will see this in a minute. So we open in the Azure command line. We're using the bash, not PowerShell. Then we just copy pasting these 4 rows. And we doing right click with paste, or you can do just Ctrl-Shift-V and clicking enter. As you can see, subscription ID should be the correct one, because the name is Microsoft Azure sponsorship, so everything is okay. We can proceed with just copy pasting entire script. While we copy pasted it, we pasting it with Ctrl-Shift-V into the console, and the deployment is underway. While deployment is underway, I would briefly explain what's going on here. So we have a SQL Server with 2 databases in Elastic Cluster. It's the most expensive resource here, and you can later on downgrade them to individual databases to S0, or just delete them to stop consuming money, because you will deploy the script as many times as you like. There is an output of the connection strings and some replacements here, but this connection strings would be at the end output of entire script execution. Then we proceeding with AKS infrastructure. We creating a resource group, we creating a new cluster, and we creating private container registry with identity to assign, so we can authenticate it with our Kubernetes cluster. Then we enabling add-ons for our Kubernetes cluster, and then deploying the service bus queue. We're not creating any topic here, because later on with DAPR we will switch to the topic, and this topic would be created automatically, and we will have a look at this. So it's service bus connection string would be output of our deployment also. Then we create an application inside instance and getting this instrumentation key. Instrumentation key is a legacy approach and will be deprecated in favor of connection strings, but for the sake of brevity, we're using the instrumentation key here. So it's Azure Container Instances. We're just preparing the group here for the deployment, because we will deploy everything regarding container instances at the step of container instances, because you preparing deployment by referencing the container that already shipped to the private container registry. And so then we're deploying container apps. With container apps, we deploy log Analytics Workspace for logs. And we create an only environment at the moment, because we will create application where we will be deploying our solution from Visual Studio. But if you want to, you can easily uncomment this section and do the container app deployment if you want to, and if you already have the image name and authenticated container registry. Then we add in Azure Key Vault. Additional and extensive configuration for our application is out of the scope of this workshop for simplicity. You can find all the changes for referencing Key Vault and adding this data in my other repositories. And as the last step, we would output everything to set a local secrets. So it will be setx command, so all the secret strings would be added to your local environment. And let's switch back to our Azure deployment. It's still deploying, but as I mentioned, I have deployed the initial version already. And while you can see that container landscape cluster without postfix already deployed several days ago, the new cluster is deploying at the moment. But let's see on the entire deployment. So we have a container land cluster, container landscape registry. We have the data group with 2 databases and database pool. We have our container app environment here and log Analytics Workspace. We have extras folder. Extras folder contains the key vault, service bus namespace, and application insights. And we have group container land instances, where as you can see already, where we have already deployed one of the instances. Our infrastructure is still deploying, and last but not least, there is additional auto-generated group for our Azure Kubernetes cluster. It's called MC Container Land Cluster something else Europe, but it's auto-generated name. Essentially, we have a network security group, public IP address, virtual machine scale set, and virtual network here. Also managed identity for our container registry and load balancer. One thing here is that you can connect your virtual network from this group to your Azure SQL Server to avoid issues with authentication. As I mentioned, I don't have a goal to take several hours to work on every step of this workshop. My goal is to do the overview so you can experiment for yourself, because it was a huge work to prepare everything for you as a step-by-step solution. So let's open the local containers quickly. For local containers, it's super simple and straightforward. It's monolithic solution for the moment, because usually it's easier to start with monolithic solution and then do the kind of split. You can observe split on the later steps. But so far we have 2 controllers, order and delivery controller and startup file. What I have done previously here, I just use it add new components and add the Docker, add container orchestration and add Docker. So if you added container orchestration, you will have a Docker compose file here. And if you added the Docker, you would have a Docker file in the root of your project. You can probably have one issue with containerization from Visual Studio. It's the naming of the steps in the Docker file. So if you would not have this string from build as publish, you would experience a lot of issues, and sometimes Visual Studio will not generate this Docker file properly for you. So be aware that each step in the Docker file should reference previous one. So it's a from build as publish, because this is step build. So from this step we continue to this step. It's one moment, and as I mentioned, everything is documented. So essentially, on the empty solution, you will need just add the Docker support and container orchestration support, like on the screenshot inside the GitHub inside the GitHub repository. One important moment is to not forget to switch from the debug on the local solution on your project to the Docker Compose, because otherwise you would have an error and spend some time to figure out what's wrong. Regarding services, just a brief overview. They will change significantly and evolve, but they created for simplicity. So we have an order service when we're receiving the order, and we're using for the moment HTTP client factory, and we're doing everything in a dummy way without database. Database we will connect on the step with container apps. So here we just doing simulating create new delivery for order, and create new delivery actually call another controller here, but we calling another controller here by the name of this container. So it will be easy to locate it by the known name inside the Docker Compose. As you can see, Docker Compose knows that there is a DAPR orders service. So it will be located, and we not using HTTPS at the moment. So switching back here, all changes I explained here. So we change it from the direct port and localhost to the DAPR orders IT. So switching back here, switching back to orders controller, it's a simple HTTP request, and we will receive a dummy response without real ID numbers and etc. Real ID numbers would be on step 4, when you will get connection to your database and where you can get outputs of everything that you created. We can switch back quickly to the Azure portal and see that something is still deploying here. So we don't yet have our outputs of secrets. And don't worry, before the publishing of this content, I will delete everything, so these secrets will be no use. So switching back, so if you need to start this application locally, just do the Docker Compose and everything will run smoothly. It will be always the same output because now we're not connected to the database and no real IDs are generated. So we can close this down and stop our solution and proceed to the next step. And so we gradually move into the step with container instances. As it documented here, essentially you need to do the AZ login, AZ account show, and authenticate to your container registry to build and ship your container. So to do this, we can just open the command prompt from the correct step, the step 3 container instances, and then do the AZ login. It will open the new browser window in your default browser, which for me will be this one. I will select this account and close it down. So as you can see, we authenticated to Microsoft Azure sponsorship. That is the correct name of the subscription. And meanwhile, we got our outputs from the command line below, which we would need to save somewhere. So we used the Notepad++, the favorite developer tool, and we just need to remove extra commentary here. Removing this extra commentary this way, set X. As I mentioned before, I'm deployed the new environment with the postfix. So all the commands and all other things should be used with the correct postfix from your deployment. As you can see, the postfix is added after the command, and the name of the instances and etc. name it as 1983. So we can skip this for now and then just follow our guide and do the AZ account show. Essentially, it's already displayed here, but you always need to double check this and do the Azure Container Registry login. While it's logging in, following the next step is super easy because you need to open the solution itself. So let's open the SLN file. And when we open this solution, we need to do the rebuild of it and prepare a new container here. Yes, I'm enjoying the Visual Studio, obviously. And yes, we need to switch to Docker Compose here and just do the rebuild. Rebuild will rebuild the container, and while it's rebuilding, we can switch back. It's already completed. We can switch back to the command line and our tutorial. So with our tutorial, we need to check what kind of Docker images we have. It's a run command, obviously, Docker images. So Docker images, we have a lot of them, and we need and we have a dev container built 11 minutes ago, but we don't need really a dev container. We need a release container, and we need to do a rebuild solution to have a release one. And we need to slightly adjust what we have here in the tutorial. In the tutorial, we have a version 1 of the container, but now we have DAPR latest, built 3 weeks ago during the first take on this repository. Actually, then we do the Docker tag and Docker images and push container to the container registry and see the output table of the container registry. We can double check it right away, so we would not wait for anything. To connect to our registry, and we can see that we have a DAPR. It only shows the particular repository, not the versions of container for this repository. For this, we have a different command. As I mentioned, you need to create a service principal, and this service principal really should be created for the newly deployed infrastructure. And for this, you should do the Ctrl-Shift-V here, but you need to update your postfix. So postfix is 983 here. So we set in but it's 983 to our variable that we have in our repository description, and with this name we can create a registry principal. So its registry principal can have also this postfix 983. Am I correct? Yes, I'm correct. And so this way we can generate our password and username to authenticate to our container registry, so we can deploy everything that we have. So just copy pasting this and putting this to the Azure. So yeah, now you see the secrets. After a few minutes, yes, this output includes credentials that you must protect, but it will be deployed soon enough. So we have a principal ID here, and we have a service principal password that we can use to deploy our container instance application. The thing is, with container instances, it's quite limited, and it's not intended for massive scale and etc. So if you have as I mentioned before, it's for simple cases. If you have 1 or 2 containers or 1 container with a sidecar, if you want to use container instances placement groups, then you can deploy it at will. So, as mentioned in this tutorial, I removed some secrets from here, but it's not that important because it will be deleted. We can also get a login server, but essentially your login server it's the name of your registry where you will be able to authenticate. And so then we can create in our resource group Containerland instances, new Containerland Azure Container Instance, and reference container deployed to our group. But the thing is, we not yet deployed it because we authenticated the different container registry at the moment, but it's not that important. So with this command and the password generated for you on the previous step, you can safely deploy your infrastructure. Just let me copy paste it, put it to our super secret file, and we will deploy this in a second. So for this we need to check a few things. First, we have to have the new image. For this I started the docker images command. As you can see, the DAPR orders latest was created in release mode 5 minutes ago. So with this being said, we need to switch back to our GitHub and check what's changed in terms of our authentication to Azure Container Registry. So we need to do the ACR login to the Containerland registry, but with different name. So with different name, it should be something from our secret. And from our secret, it's 983. So we just adding it here. Okay, login succeeded, and then we need to, according to our tutorial, just tag our container. So newly built DAPR orders latest, we will tag it with proper container registry name, which in our case should be 983. So it's container registry 983 DAPR orders 1. It's super important to tag your container with the name of proper container registry that you authenticated. Yep, and we can do the docker images, and we'll see that we have the properly Containerland registry 983 DAPR orders tagged containers, and then we will need to slightly adjust our deployment script, but first we need to just push it to the remote, so it will be like this, and with the same update of 983. So we hit enter and see that our container is pushed to the container registry. Give it a second. Yes, it's over there. For the sake of brevity, I'm mentioning again that I will not be doing each and every step because they are quite self-explanatory, and I will do the most interesting part here. So we can do the list. Essentially, we've done the password thing, and what we need to do is to slightly adjust this command so we can deploy our application. So, but before we deploy our application, we can close down this output because we saved all the secrets here. And if you will switch back to the resource groups, do the refresh, and we have this instances group with previously deployed container container instances, and we have a new group without any deployment here, so it will be a fair play. So I copy pasted the command, and what I need to do is to check the correctness of the names. So the container land instances is 993. Let it be also different name, 983 of the ACI itself. Then we need to switch name of the registry to 983 also. We have a container v1, we will have one CPU and 1 GB of memory. And now it's interesting part, because we need to adjust this command for the login server. It's Azure Container Instances login server here. And registry username and registry password. And we will switch DNS also, DNS name here. So we need to use this ID as service principal to deploy our application registry username here, and the password is over here. So quite straightforward and quite easy. It's registry password, yes. And we have the deployment string. Let's do the deployment. Let's do the deployment thing. You can do this from our local CMD or from the Azure portal. It's not that important. And while it's deploying and everything would be set up, let's follow our output. So you can monitor deployment of the container instances with the following commands. And you can check the logs and see the outputs from our logs quickly. The thing is, the application itself, if you will follow it step by step with changes, there is a wrong URL. There is a internal, there was committed initial error was with the reference name inside the string URL. Now it is the latest version and it should be fixed. Let us quickly check. It's order controller, and no, it haven't been checked in. It's good actually, because we need to rebuild the container and push it again so our application will work. So as you can see, we're using here the real name of our application deployed to Azure. So I can open this solution. It's good that I kept it in the wrong way. So you would have to do some changes following the guide inside the README file. So I changed it here. And if you would see our deployment result, it actually deployed and working properly, but it will be error 500 when I try to reach out our application with the URL to query and create order. So if you will open our container registry name here and add the 983, we would get 404, because obviously there is a different URL here. But if we open Visual Studio Launch settings, we can find our API order create path, add it here and execute, and we get a nice 500 error. This 500 can be observed with the commands from the tutorial, as I mentioned, so it's super easy to figure out what's going on. But don't believe me, just believe your eyes. So AZ container logs, it can be also connected to the, let's do it from the portal. You can also connect this to Azure's Log Analytics or Azure Application Insights. So with this being said, let me do the abort. And as you know, we have a slightly different names here. So it's a 983 and 983. If we can see the container logs, we can see the exception in there. Yes, and we can see detailed exception, so TPaper orders 80 is not known. So this approach can be used for each and every step of this workshop. If something don't work, it's because you need to be following exact instructions on the GitHub. So switching back to Visual Studio, we see that we changed this in our order controller with the proper URL. And with the proper URL change, we need just to rebuild it. And our rebuild is done. So we need to check Docker images first. We see the latest build 34 seconds ago. We need to tag container with v2. Then we will need to push our container Docker push to our registry and change the version to v2. Layer already exists, just the changes push it there, completed, and then we will need to redeploy our app. But to redeploy our app, we need to just click up and down to find our command. Then we can just hold the left button to navigate to our TPaper orders v2. And here we replacing v1 with v2. Oops. Sorry for this. I should hit end. And our deployment is complete, and we can switch to the browser and quickly navigate to our endpoint, and as you can see, it's working. Now we're switching fast forward to the container apps and container apps with DAPR essentially. So I will deploy and initialize our container app and switch to the DAPR step because we don't have much time. I hope you're already familiar with the solution. So I will show the changes that we have here. So skipping to the container apps, we will use DAPR components to switch to the Azure Service Bus queue for inter-service communication. So we opening step 5 container apps. We opening the solution here and continue to following steps, but let me just briefly mention what's happened here. Our solution is split into on the step 4 for container instances, multi-container group. So we have, if you will follow the step 4 information, you will have the same application with 2 services, TPaper orders and TPaper delivery. We already have a SQL Server connected to our both projects. You can run locally if you applied the local secrets and restarted your machine. So sometimes the path variable is required this. We have a startup with injection of the local environment variable passwords here. We also have controllers in different projects here, and order controller on the step 5 using the same HTTP client factory, but it uses the delivery URL secret. Delivery URL secret will be the name of your container app instance. And with this being said, let's start with our deployment of the container apps. The hint is the first deployment of the container app by the flow should fail for you, because there will be lack of the secret assigned. But explanation on how to assign the secrets is shown here. To speed up things, you should do the following interesting part. You should open your SQL Server. So let's open it in any group, container land data. You can connect the SQL Server and this description inside the README. You can connect it with VNet, with networking settings, with your Kubernetes cluster and container app, or the IP address of your of your Kubernetes cluster or container app dedicated one, or you can allow to access entire range. So if you will, you can add a virtual networking rule and use your VNets from your Kubernetes here. You can also add VNets for the container apps, but this is kind of advanced scenario. As I mentioned, you can add a firewall rule, just essentially allowing all, and it will start with 000, the mask, and end with range 255, 255, 255, 255. Essentially, it's allow all rule. And let's save it. And we don't need at the moment CMD line, so it is saved and it can be accessed by any IP address. So this will allow you to use SQL Server at will. So let's deploy our services. So we will open the DAPR delivery, select publish. And as you can see, there is a wrong name of the container registry and everything is wrong here. So we need to add new publish profile. So we need publication to Azure Cloud, yes, specific target, and it will be Azure Container Apps Linux. There is no support for Windows containers now. There are no container instance now deployed. So we selecting our container land container app here, and we using container apps environment North Europe that we created before. Container name DAPR delivery, because we deploying DAPR delivery service, and we creating the new Azure Container App for this service. So it will be 2 Azure Container Apps because it's a rule of thumb to deploy each container app to the dedicated service. And as we can see, it's already created. Then we hit next and selecting the container registry from which we will be populating our application. It's quite important moment here. Because different registry can contain different versions of containers. I will use for this step container land registry without postfix. And next, publish file. But you can also set up CI/CD GitHub actions and work with your application in production with easiest possible way. And with this created, we can select a proper one. It's container land Azure Container Instances IO. And when we will hit publish here, it will build our project and it will deploy it. So we can see this. We can see these publish profiles over here. So as you can see, the new DAPR delivery app is created recently. It's also visible via changes to the Git. Here is the one. It's paper delivery app. So everything is correct. We can hit publish. As you can see, it published successfully. Now we can do this the same process for the DAPR orders, but on the first publish we will create in Azure Container App. But on the second publish we will add secrets to this container app, so it can work with secrets, and so it can work with SQL instance and use configured value to connect to the configured between services. One important point here is that when we need to create a new container app, so we would have a DAPR delivery app and DAPR orders. So one container app per service, and these container apps can be deployed in the same in the same container app environment. If we will briefly switch back to our browser, you can see that TPaper delivery is deployed and running, but it doesn't mean that our services can communicate with each other, unfortunately, because to communicate you need to add application settings to both of the services. Because you need to add communication settings to both services, as explained in this tutorial. You should get a proper URL of the application and allow to make unsecure connections with HTTP allowed. Let's do the switch. So we need to set up Ingress. We will back into the resource group, opening the container app that we have here. As you can see, TPaper delivery is here. Yeah, we checking our DAPR components would be located inside the environment, because it's essentially environment, it's the same virtual network and same namespace. So we're switching here, and we opening Ingress. And here is allow insecure connections. We're saving this while our TPaper orders is already created. So we hit next, select the container registry, this one, and generate publish file. Profile is being created, but we cannot navigate yet because it's still updating. Here configuration can take some time. Publish profile already created for us, and we need to do the actual publishing. So we do the publish now, and after the publish we will add the secrets, and this would be like initial step completion for the container apps. I will briefly mention how to add and switch DAPR, what kind of changes on the next step, but we will switch back to the AKS and the step with switching, adding and switching pub/sub components. So we will switch off so we would switch off from the Azure Service Bus to RabbitMQ. Publish and succeeded, and hopefully configuration is saved here. Yes, it is saved. We would refresh. Yes, we have our TPaper order and we have TPaper delivery. So we're switching here, refreshing this one. So while we refresh it, it was not visible, but now it's visible. We can see TPaper orders here. And what's important here is that you get the site URL here, and this site URL is opening in the browser. So you have exact names of your application. We would briefly switch to Ingress and make it HTTP allowed, insecure connections allowed. While it's updating, we can have a quick look into the code, so we can see the order controller here, and we see that this delivery URL section. Essentially, delivery URL, it's the URL of your container app, and as explained inside the step, you should get a delivery URL and set and as you can see here, you can add this URL to environment variable in Docker env file. Docker env file located here in settings environment, and it's referenced in the Docker Compose. Docker Compose is quite different at the moment, so it have two services here, and both of them using the same settings env file. Settings env file is essentially your configuration and secrets that will be used when you run your several services, and delivery URL inside the Docker, it will be TPaper delivery port 80, but for our For our cloud environment, we should use delivery URL secret. So delivery URL secret would be this URL, but copy pasted from the deployment of DAPR delivery. So let us switch to the DAPR delivery, to the DAPR orders, because we need it here. So it's a publish. And here you can see manage container app settings. So we add in settings here. The name of this app setting is delivery URL, and the value, this is DAPR delivery app. This is the first one. Then we need to add few more secrets. It's the secrets that we copy pasted from our output. So it's a SQL paper string. Let me quickly do this. And SQL paper string, for me, I will not use 983 at the moment, so it's super easy to guess all the secrets. If you're willing to try, we add in more secret values. We using SQL paper password here. So SQL paper password is super strong. Delivery password is the same, but we need also this service bus string. So it's a service bus string. It's for the next step that you will be doing, but you can set up it right away after the deployment of first container app. So it's 3 secrets here. These secrets would be applied to the Azure. We republish this service, and the next step we would configure the secrets via publishing of this application. One thing, there is a different ways to adjust the secrets and set them up. So essentially what we done just a few seconds ago, it will appear right here. So you can set all secrets from the Azure portal here. And as you can see, there is a bunch of the secrets, but what you should be aware that these secrets have a kind of Kubernetes-like structure. So as you can see, our application is really working now, and it's provide the 404 error. Then we need to deploy the next one and configure the secrets there from the Visual Studio or from the Azure portal. It doesn't matter, as I mentioned before. So it's a DAPR delivery, it's manage container app settings. There is no direct link yet between container apps and Azure Key Vault, but this is something will happen next year. So we're using slightly different secrets. We're using SQL delivery password here, and the value. Then we add in the connection string, SQL delivery string, and we add in the server name without 983. But for you it will be your favorite prefix. So it's 2 secrets. They will be added momentarily, and we would hit the publish and wait a few seconds. And after our deployment is ready, we can observe the results. So we have our container app here. It's a DAPR delivery, and I added the proper URL here for our DAPR orders. And when I'm clicking, when I'm sending request to this endpoint, you can see that accepted EDI message is number 8. So as you can see, the EDI message number is changed every time, because we're saving it to the database and outputting ID. And what we have in the second service? In the second service, we have delivery controller, and we have a health endpoint here, and we have this endpoint with creation of the messages. So this step is so this action actually concludes the step 5, because it's still a lot of content to ingest. But after this, you will be able to work with your container apps and call them. One important point here, that this public URL can be added with internal ingress, so it can be something like this, internal. And if you add this as internal URL for your delivery URL inside the DAPR orders, all traffic between your services would go through the Azure backbone network and not hit the public internet networks. So essentially, you can just add internal here. So it's to be like this, and after a deployment, everything will work as usual. But this is also described in the GitHub repository README, so you can do this by yourself and get back to me if you will have any questions. And so, before we move to the last and most complicated step of it, it's the AKS component switch with the DAPR. I would briefly mention the DAPR step. So for this, we would open the DAPR Container Apps DAPR repository and look for the changes. You can deploy the new version of Container App with DAPR component super easy by following the steps inside the repository. And here we have our solution. What we have here, we added the DAPR SDK here, version 1.9.0. It will be 2.0 soon, so you can easily upgrade there. And with our controllers, we just use the name of the topic pub/sub bus and create delivery method. And with order controller, we call it the same pub/sub bus and create delivery. So we publish an event async. There is a changes inside the startup file, map subscribe handlers, and other changes that I mentioned inside the README file. So if you will return here and essentially navigate to the correct point, it's container instances, and yes, here we are. Create delivery for order in DAPR project, and adding the DAPR ASP.NET Core, changing to publish event async, and adding the DAPR inside our startup file. So it's super easy, and this way you will switch from usage of HTTP to the pub/sub component and make communication between your services reactive. Then let's switch to the migration to the Kubernetes service. So if container apps is not enough for you for any reasons, and you need advanced networking and advanced scenarios, you can use Azure Kubernetes service to start there, to deploy your containers there, and then use it with advanced networking and integrations with different resources. For this, we need to build our solution and deploy our two containers to the Kubernetes cluster. But before this, we need to initialize the DAPR, check the DAPR deployment inside the cluster, and then only we can proceed with our deployment of the services and deployment of manifests. So let's follow the flow and start with logging in from the correct from the current directory to our Azure Kubernetes service. We would open the proper step. So it will be Azure Kubernetes service. We do the CMD from here. Yes, we in the correct folder. Then we collapse this and just quickly check. So we have everything we need besides the service bus. Beside the service bus secret that we will need to assign to our manifest. But before this, we would do the login and do the context switch to the Kubernetes cluster. So essentially, we will do AZ login again. AZ login, it will open the new window. We would select my account. Then we can close this down. It will be authenticated here. So we can just switch back to our window and check if everything is okay. So we're doing the ACI container registry login. We're getting credentials for our cluster. We're using context of our cluster and checking the kubectl with the namespaces. We would do the paste anyway. ACI login would take some time for us, but before we will convert this to the secrets, I'm getting all namespaces here. Getting all namespaces here, and we see that everything is deployed to the Kubernetes in terms of clean services, but nothing in regards of our application, which is what we intended. So let's init the DAPR. For this, DAPR CLI should be installed on your machine, and this command will init the DAPR inside your Kubernetes cluster. We will check up this with DAPR status -k, and we still in this folder, and we would need to do the secret file. As you can see, there is a connection string for the service bus and connection string for and not connection string, but a password for the SQL. We need to put them as base 64. Obviously, it's better to. It's not better. It's what is needed. You need to use the Azure Key Vault, but for simplicity of this workshop and avoiding extra dependencies, we're doing this via secret file. And so the DAPR is initialized. We will check the status. As I explained it, we will generate the base 64 for these two secrets, and it will be secret password for our namespace DAPR, and it will be connection string for service bus. As in tutorial, we're opening the base 64 encode. For ease of use, we're taking our secrets that we store it right here. So I'm talking about secrets that's related to the password. So it's 983 without 983. So we're putting it here and telling it to encode. Then we opening this AKS secrets, and we checking that we put in the correct one. The password here is this one. Don't forget the save. And then we need a service bus string. Service bus string would be this one, also without 983. Because I'm trying to speed up things with this explanation. Yep, we're copying it. pasting it here, encoding, and copy pasting it back to the AKS secrets. Yep, and it is here. So we have this YAML with secrets. So we can later on continue with the flow. So we changed the secret file. We done the AZ login, and we seen what's going on with the cluster. We initialized DAPR. Now we need to open the solution actually and to build it. So we would have two containers. We need to tag two containers and put them to our registry. It's still named the name of the version of the containers here. It's version 1. It's not correct, obviously, but let me quickly close everything down what we don't need and reopen DAPR orders here. DAPR orders here. It's opening and it will be ready soon. So it is ready, and now I need to rebuild this. So we would have two fresh containers. Meanwhile, we can have Docker images here. Docker images, yes, we have a lot of stuff going on here. Uh, 25 minutes ago, yeah, a lot of containers. I need to do the cleanup after this. It's building. So it's already built, and let's have a look into the command line and see the Docker images. We see the latest build just a second ago. It's two of them, and we need to prepare them for deployment to Kubernetes. So it will be like a v10. Container land registry, yes, it's target with v10, and paper delivery would be a v10 also. So it's ready. Now we need to do the Docker push of the v10. One is there, another on the way. The next important part is to update container version in order and delivery service manifest. As you can see, container manifest contains the name, explicit name of the connection strings. We will need to change it. So we will need to change it a little bit now. It's referencing the secret, and it's using exact container name. As you've seen, we pushed the version 10, so we need so everything is pushed up. We would open the YAML folder inside our solution, and we have a lot of YAML files. So it's a namespace, PubSub component, but we need these two files. It's DAPR orders and DAPR delivery. So as you can see, there is a v2 already here, but we put in the version 10. Don't forget to save this stuff. And as you can also see, if you will be following the flow here, it will have a correct values. But here you need to check for the SQL Server name. So it's cont length. And the same goes here. It will be already fixed for you inside the repository. I mean, this manifest inside the manifest file. So this manifest just describing the service. It's load balancer with port. It's secrets and the reference of the Kubernetes secret. So we exposing with each service DAPR sidecars. And they will be responsible for communication between the services. So we have saved these two files, these two manifests. PubSub component for the DAPR should use a proper secret from Kubernetes secrets, and here's the reference in place. Everything is fine. Then it's a manifest to create a new namespace. Namespace is the way to organize your clusters properly in a fancy way. Let's proceed with kubectl commands inside our command line to deploy all manifests one by one. So the first one would be the namespace deployment. Actually, I'm using quite a good tool called Lens. With it we can observe our cluster, and it doesn't matter which cluster and which cloud it deployed. AKS namespace DAPR does not exist because AKS namespace, yeah, because I need to switch the folders. So cd YAML and kubectl apply. Yeah, a namespace is created, and the new version is already there, but we don't need it. We need to browse clusters in the catalog. It will take a few minutes, and we can see that we have a container land cluster here that we authenticated just recently. So we're moving forward with our flow. After the namespace, we applying secrets and pops up service bus. We can do this with passing commands one by one. A secret JSON cannot unmarshal number into Go struct with uint. And we got this error because we not properly placed the secret. So as you can see, we left the SQL secret here with the wrong string. So we can do the Ctrl-Z, and the error was because of the int value. So we will correct it and just redeploy. Namespace AKS secrets. It should go properly. So one secret is updated now, other one is applied. As you can see, we should put connection string here for service bus and password here. And with this being said, we need to apply our PubSub service bus. Yep, we applied, newly created. The next step is to apply our two services to the Kubernetes. Paste anyway. Hit additionally enter. And we have our services there. You can use these shortcuts to republish your services at will. One thing that is important is to have is to know the IP addresses, so you can check if your connections is working properly. So what you will need for the moment, you need to if you have a lens, it will be super easy to fetch. If you have a command line, it's not that complicated also. It's not that complicated also because you can get you can run the kubectl get all namespaces, or you can run a command for the particular namespace. Here below I'm explaining how to get results via command line, how to get logs, and how to get proper information, and how to do debugging with Lens and other means. But let's do this. Get all namespaces. But essentially what we need to do is to get these two IP addresses. So as you can see, we have an address of the DAPR delivery and the public one, the internal one in Kubernetes and public one. So it's we can just copy paste these IP addresses and URLs to the new text file, or not to the new, but to our file with the secrets here that we worked with. So it's wrong IP addresses, but we will fetch them. It is IP address for the DAPR delivery, and the next one is the IP address for the DAPR orders. like this. So now we have IP addresses to query our endpoints. And if we will scroll up, we would see that something wrong with our images, and we need to investigate what's going on there. And the easiest way, as I mentioned, is to have a lens ID, but the other way is to get your logs for your containers here. Essentially, if we would open our cluster in Lens, navigate to pods, scroll down and see our pods are in pending state, and click here to get information, you can see that Kubernetes is failing to pull image. So what we need to do to quickly check the name of our container registry, and we can see that it's a wrong container registry inside this manifest. So we need to fetch the correct one. The correct one would be taken from the Azure portal, because we have it right here. So it's container app, not instances, cluster, container length cluster, and we have cont length registry. So we need to redeploy this by changing container length registry here and here. So we save with these two files, and we don't need to tag anything or do anything else. We just need to apply again DAPR delivery. It's called configured, and then DAPR orders. So we can see the results with kubectl get all namespaces. We can switch to the particular namespace to see what's going on there. But as you can see, we have already DAPR delivery running and DAPR orders running. So it's quite successful deployment and delivery. And so we see also a lot of DAPR components here. And we also see DAPR sentry operator and dashboard. It's something more related to the DAPR, not for the evolution of container app on the Azure. But you can have a look into the different workshops that I have on my GitHub. And as you can see, there is a namespace, DAPR, and we have a DAPR pops up component here. So it's time to check if our service is working. And so if we will try to use our... And so if you will get this information, then we can switch back to our temporary file, use following IP addresses in our routes, and see that our messages are working properly. You can use additional URL, obviously, to get deliveries and to move forward, but there is not enough time for us at the moment to look into the old details, but there is not enough time for us to look into the old details, but you can do it at your own time. So everything, as I mentioned, is described here. And also I described the working with the lens and how to work with the services and how to debug them inside Kubernetes and etc. So the next step would be to just switch and use additional component of the RabbitMQ. So essentially we'll deploy the new RabbitMQ instance to your Azure Kubernetes cluster. And then just switch and use different DAPR pops up component. It's super easy to do, and I encourage you to follow the last step. You can do also some external tasks that I mentioned inside this repository, and also you can have a look into the Lens IDE because it's a great tool and it's super easy to work with the clusters and just watch your deployments, do the restarts, and see the exact pod logging. But also I mentioned everything as a command line, so you can debug your services and connect them via kubectl. So essentially, if you would do the kubectl config context set, you would have your DAPR only, and you don't have to get all namespaces to get understanding what's going on with your application and your services. This will work essentially with any Kubernetes cluster, so it's super easy to see what kind of components deployed and what's going on here. I'm well over the time. Thank you for joining me on this short overview of the workshop that is intended for the entire day. I hope you will enjoy the flow of building and migrating your container application between different services. So it is a container apps, container instances, and Azure Kubernetes service. And essentially, with help of distributed application runtime DAPR, you can migrate your application to any cloud and any on-premises later on. So, it was a super crammed information because this workshop is intended for entire day. I hope you enjoyed it, and I hope to see you soon on the conferences and other workshops. So happy holidays and happy new year. Cheers!